Okay, hello. We have finished with the first part of relation and function, that is Cartesian product. Cartesian product we have finished in the first video, and I hope that you have gone through it. Now, in the second video, we are going to present before you the relation. Right? There are two parts, relation and function. So we are going to now present before you the relation. First, I'll write a definition and then we'll try to work out the whole thing with the help of a model so that we'll get the exact picture what relation is, and then we'll try to understand by more examples in the board, right? So first of all, I'm going to write the formal definition of the relation. Let's start with, right? So relation. What is a relation, right? A relation are on a non-empty set, right? Non-empty set A to other non-empty set non-empty set B is a subset of A cross B. Subset of A cross B. A cross B means we already did it. It is the Cartesian product. So if we have two sets A and B, then we can find their Cartesian product. Okay, one condition is there, that we should have both the sets non-empty. In that case, whatever is a subset of A cross B, whatever may be the subsets, maybe the empty set, maybe the complete set A cross B, or someone in between, proper subsets, each of them are said to be a relation. We denote usually this by R. If more number of relations we need to use, we'll write R1, R2, etc. Right? So this is the basic part. Let me go for little more explanation before I take the model. Then just let us try to observe how many subsets will this particular A cross B have. Then we can tell you how many relations from A to B will be possible, right? So just try to remember, if n number of elements are there in a set, then 2 to the power n number of subsets are possible. It is from the set theory. So can you tell me what is the number of elements here? Clearly, number of elements in A cross B, already we got that in the previous video, that it is simply the product of the number of elements of A and number of elements of B. Therefore, total number of subsets of A cross B will be how many? 2 times. Anyway, I'll not write this part, I'll write it like this only. So if A cross B will have 2 to the power n A cross B number of subsets, then each of those subsets are relations from A to B. So I can write, therefore, total number of relations from A to B is 2 to the power n A cross B. So this is a very, very important conclusion we have to remember, right? Next, out of this, again, there are two more which we have to remember. If by chance the subset you are considering, the subsets of A cross B you are considering is a null set phi, then it is called, R is called a null relation, right? A null relation, or you can say an empty relation. And if R is the complete set A cross B, it is called universal relation. It is called universal relation. So these are the things at the beginning you have to be very, very clear and now make sure that you do not have any kind of drawback in these particular things to understand, because once we enter in functions, these are going to help you immensely to understand function in a very clear way, right? So now I'm going to demonstrate these things with the help of a model which will help us to understand what relation is, how it can be depicted in a figure, right? So I'll be taking a little recap also of A cross B. So here you see here I have considered two sets. I did not mark it so far. This one you consider as A, this as B. Set A contains these 5 elements. Set B contains these 4 elements. All are distinct. Okay. Now next, if I ask you, you find A cross B. A cross B. A will be first, B will be second. Then with this element, red color pin, we have to relate all these other elements of the other set. We have to create ordered pairs. In the last video, we have got it. For example, momentarily, if I consider this as 1, 2, 3, 4, 5 and this as A, B, C, D, then this one has to be related to A, this one has to be related to B, this one has to be related to C, this one has to be related to D in order to write A cross B. This is what I am talking about, this element, which are shown by the rubber band, right? Purposely I did not mark these relations. Now for A cross B, from here also you should have similar rubber bands which will show that this element will make a ordered pair with this element as well. So now just think if one element has 4 such ordered pairs related, because there are 4 elements here, so 4 ordered pair will be there, and second element will also have 4 ordered pairs. This will also give 4 ordered pair, this will also give 4 ordered pair, this will also give 4 ordered pair. So for each you will be getting 4. How many are here? 5. So total will be 5 into 4, right? That's what we have the formula as number of element in A cross B is simply the number of element in A and number of element in B product. That is 5 into 4. That's what we got. This is for the Cartesian product. Now imagine if I give you a task that you have to just depict A cross B in the figure, this figure suppose. So what you will do, you will have to now use rubber band to connect all these elements, right? Meaning is that from each of these pins you have to get 4 rubber bands till you complete everything. That means there will be 20 rubber bands. Okay, that gives you 20 ordered pairs. Now by the word subset, what will mean? It may be that all elements are related, or maybe one rubber band is missing. Matlab, if one rubber band is missing, suppose one rubber band from here to here is missing, suppose, then we'll say that this element is not related to this. Okay, by this rubber band or by the presence of the ordered pair 1, A, I want to say that 1 is related to A. That is what you have to understand. 1 is related to A. And if there is no rubber band between two, that element is not related to the other element here. Is that clear to you? So now if I draw all rubber bands A cross B, if I drop some of the rubber bands like this, it is a subset of A cross B, which is also a relation. And if I do not keep any rubber band, that is empty relation, right? So you got this demonstration here. Now here only I would like to tell you, when you construct a relation like this, in this particular relation I have only related this element. So these elements are not related. These elements are not related. So only this set, it is a singleton set. If I relate more, it will not be a singleton one. So this particular set, a particular set containing only this element, is known as the domain of the relation. And whatever are the elements related with this from the other set is called to be the range of the relation. Range, remember it, there is a difference. This is a range. An entire right side set is called to be the codomain. It is a chance here that I have related all elements, so domain and codomain in the range both are the same. But sometimes if I suppose remove this rubber band for a moment, if I remove this rubber band, so here you can see domain is this element, singleton set, and the range is this three, set of these three elements, whereas this whole four elements is going to give you the codomain. Am I clear enough? If not, again you replay the video and try to see this. You will understand. Then before I write anything over there, let me again try to tell you two definitions, very important definitions. If I say that this element is related to this, I have to get an arrow here. This is represented by the rubber band. Once we draw arrow in the figure, then we call it arrow diagram. Actually, this is a arrow diagram. Then this element is known as the pre-image of this. For this also, I am just taking one order pair. It is related to this. So this is pre-image of this one, and this is image of this element. Please remember these two words very, very clearly. This element is known as the pre-image of this, and this is the image of this. Now in this particular figure, just to say, this is pre-image of each of this, whereas this is the image of this, right? This is the image of this, this is the image of this. Okay, so this is what we would like to demonstrate with the help of this particular figure, right? This is going to help you immensely when we take functions. Let's go to the board and we'll note something so that we have a clear-cut idea about the theory part, right? I'm taking a little more time to explain you this because we need definitely these things, otherwise functions will become very, very difficult for us. So now we are coming to the notations, right? With depiction of that figure. Suppose this is the set A, this is the set B, right? If I find entire A cross B, then from each of the element, I am considering those elements only what I mentioned over here so that you can comprehend easily, right? If I relate each of the element with that, then I'll be getting A cross B. And then whatever relation is produced, we name it like this. This is the symbol we use, right? And how do we write this? As a presently, I did not relate any elements here. Presently, right at this moment, I'll do that. For symbol, what I'll write? I'll be writing it like this, right? R such that A to B, right? R such that A to B is a relation on A to B, where now this R is going to tell you exactly which elements are related. If I just say that 1 is related to A, so in R I should include 1A. If suppose this 5 is also related, 4 is also related to A, I should write 4A. Suppose this 3 is related to D, I should write 3D. And then suppose this 3 is also related to B, I write 3B. Right? It is not at all necessary that I should get arrowheads from each of the element to the other for relation, right? Because relation is a subset of A cross B. Now very easily you can verify. If I find A cross B, then ordered pairs will be there. Out of that you can see only selected ordered pairs are here, which tells you that elements from this are also related to elements of this. Not all necessarily. Only the arrowheads which are drawn, they are telling you which element is related to what. Right? That's what I explained over there. So this is the relation, whatever I depicted in the figure. Now supposing that I draw one more like this, then this will not be that relation. I have to include what? 5 comma D. Am I clear enough? Now once I write the relation like this, the first place element of these ordered pairs, first place element, they are constituting a set which we call as a domain of the relation. That means we define this as D of F, and it contains what? 1, 4, 3 and 5. You see, you need not repeat. Already in set theory you got, if one element is repeated twice, thrice or maybe more than that, we should not write it that many times. We have to write only once. So 3 is repeated twice, I have to write only once. So 1, 4, 3, 5 is the required domain. Be very clear, in A there were elements 2 also, but in this particular relation 2 will not be counted in the domain because 2 is not related to any of the elements of the right hand side. Am I clear to you? That is a special care you have to take. After that, if you consider the right hand side place element in the ordered pairs, they will tell you about the range, right? Range of the relation. How do we define? It is range, we write it like this. It contains all the elements which are related to some of the elements of this domain. So we will be including here A, B and D. Will C be included? No, not at all. Why? Because you can find C is nowhere related to any one of the element of this left hand side set. Is that very clear to you? So concept of domain, concept of range, very important. Then overall, whatever is the set in the right side, when we write a relation like this set I am talking about, it is called codomain, which in short we might write like this: C D suffix R. R means codomain of the relation R. If it will be R1, then I'll write CD R1 suffix. Okay. So this is all about the idea of domain, codomain and range. Once more I'll repeat, the elements which are in the first place of the ordered pairs, in the figure the elements which are having some relatives here, in the figure I can say like this also, that those elements from where arrowhead starts, they are constituting the domain. And code range means the elements which are in the second place of the ordered pair. When I write R like this is what? Roster method. In roster method, if we write second place element will constitute the range. In the figure, those elements which are having some relatives here is constituting the range, or else I can say that those elements which are having some arrowheads coming to it. There is no arrowhead coming to C, so C will not be there in the range. And the entire set B in the right hand side is the codomain. So these are the glimpses what you have to always remember, right? Next, what is the very important part? I told this 1 comma A, you can see 1 comma A is here, right? That means 1 is related to A. So this one is known as pre-image of which element? A. And this A is known as image of 1. Image of 1. Am I clear to you? Now you see, image of 1, it is A, but this A is image of 4 as well. That means two different elements can have the same image. Similarly, one element can have two different pre-images. One element can have two different pre-images. One element can have two different pre-images, right? In fact, one element can have two different images also. So anything is possible in relation. One element can have more images. More elements can have same images. One element can have more pre-images, right? And many elements can have same pre-image. These all are possible in relations. That is very, very important to know and be alert for this particular part. Now after that we can start with the problem, because I have given you all the vital definitions. Please note it down very, very clearly, and then we'll start with the problem. Let's move on to the problem. Okay? Now let's start problem. Right? Question number 1. Question number 1. I'll not write the very formally questions. You'll be getting every questions in the description. So you will download the PDF format and then you will note it down in your copy. I am not writing the complete questions here. I am just explaining so that you can understand everything very, very clearly, and it will take less time. So R is a relation from A to A. R is a relation from A to A, where A is the set 1, 2, 3, 4, 5, such that, right, such that R is xy, where y is calculated as x minus 1, x comma y belongs to A. Then you have to find this. First of all, you depict it in the arrow diagram. I am writing simply as figure. Then you write it in the roster form. Right? Roster form means listing method. Next you find what is the domain. Next you find what is the range. And next you find what is the codomain. Right? So these are the 5 quantities we need to find for this particular relation, right? First of all, when I depicted the figure, I have just connected the elements without any kind of rules, just for examples. But whenever actually in practice you have to do the problems, they will give you some rules and you have to follow that rules, and then only you will find what is R. Right? So we'll go in process. So first of all, we'll try to find out what is a figure. So figure is the most convenient one. So always you try to do it in the figure at the beginning. If they're not asking in figure, no problem, but do it in the figure at the beginning so that you get the concept. It's not a prestige issue. Don't feel, okay, I should not draw the figure, I should do it directly. Right? Sir is telling that, sir is not telling like this. Well, don't go for that, because at the beginning you must understand the concept, right, by hook or by crook. So you draw the figure, get the concept, then you convert this into the text, right? So here we are proceeding like this. This time you see both the sets we have considered as same only. Relation is R here, and the elements 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. Very good. Now what is the relation once more? Again you see before you connect the things. Y should be 1 less than the x. Where from x you will take? See, first place. Matlab, it is from this set. So whatever element you choose here, it will be connected to that element of this set which is 1 less than this. So if I pick 1, what is 1 less than 1? 0. Do we find a 0 here? No. That means 1 cannot be related to any element of the right hand side set. I pick 2. What is 1 less than 2? Because if I put 2 here, 2 minus 1, 1 will be there. That means 2 will be related to 1. That arrowhead is possible. Then if I consider 3, 1 less than 3 is 2. So that means 3 will be related here like this. So I did it very quickly. So you can find that this is the figure. This is the arrow diagram of this particular relation. Is it clear now? Now the clear picture is there in your mind. So there will be no mistake now. Next, number 2. Number 2, what they are asking? Roster form. That means you have to write all the elements. So in R, you write the ordered pairs. 1, do you have any ordered pair here? No. So it is the first ordered pair will be 2, 1, then 3, 2, then 4, 3, and then 5, 4. Right? Next, they are asking you about the domain. Domain of the relation R. Domain of the relation R. So domain means, remember again, the first place elements of the ordered pairs, or those elements from where ordered arrow starts, right? So it will be what? 2, 3, 4 and 5. What about the range? Range of R means those elements which are in the second place, or I can say those elements where arrowheads are connected, right? This will not be there in the range because no arrowhead is coming towards that. So what will be there? 1, 2, 3, 4, right? So, and at last, number 5, codomain. Codomain is what? The right hand side set, that is set A completely, right? Did you get it? Definitely, once more you see, you will understand this, right? Okay, I'll be coming to the next question without much delay, right? Will not take much time to discuss these questions because these are very easy questions. Just invest little more time for understanding from your part, right? Once it will be clear, then it will be very, very easy for us to go for functions. Number 2, question number 2. What we have here, I have the set A as 1, 2, 3, 4 up to 14, right? And I have a relation R from A to A, where how do we define R? X comma y, where y is equal to thrice x plus 1 and x, y both should belong to A. Now see, I did not write the part. Same thing you have to do here also. Figure, roster method, domain, range and codomain. 5 parts. See? Okay, so let us first draw it, right? We'll convert this into a figure, the arrow diagram, right? So now you see, this is A, from here to here, this is R. How many elements are there? I need to write the elements. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, now, what is the relation you see first? Condition, criteria. If you pick one x, you should make it 3 times and plus 1 to it. Whatever you get is the value you will find here in the right hand side set. That means the value of y. So suppose I pick 1. What I should do? 3 times of 1. 3 plus 1. 3 plus 1 is 4. Did you get me what I am doing? Actually, I am putting this value directly here and I am finding what is y, because that y should be here. So 1 will be related to whom? 4. We draw arrowhead. 2. Check for 2. 2 times 3 is 6. 6 plus 1 is 7. So 2 is going to be related to 7. Then 3 will be with 10. 3 is a 9. 9 plus 1. 4 will be 4 is a 12. 12 plus 1 is 13. 5. 5 will be 5 is a 15. 15 plus 1 16. Do you find a 16 here? No. So that means 5 onwards there will be no more elements now which will be having some images here. Did you get me what I am trying to say? So your process finished here only. So that's the figure. And then number 2, if I ask you to write in the roster form, what is the roster form? 1, 4, then 2, 7, then 3, 10, and then 4, 13. That's it, right? And then if I ask you about writing a domain, what is the domain? Only this element 1, 2, 3, 4. And then if I ask you to write what is range of R, those elements which are having pre-images. So they are having pre-images. 4 is having pre-image 1, right? So it is 4, 7, 10 and 13. And what is the codomain? What is the codomain? Codomain is the right hand side completely, that is A, right? So you are finished. You finished it, right? It's an easy question, right? So please note it down. Again, I am telling you repeatedly, note it down. Okay, go on doing with us, right? Okay, so now next move on to the third question. Third question. What is the third question? In third question, we are giving you a figure, and then from figure we are asking you the questions, right? So in question number 3, there is a figure, right? There is a figure like this. This is set A, this is B, there is a relation R, elements are 1, 2, 3, 4, 5, and then this is A, B, C and D. Arrow startings are like this, from 1 and 2 to A, then 3 to B, and then 4 to C. Nothing more, right? So it is like this. First question, you write it in the roster form. Roster form, right? Arrow diagram is ready, roster form. So how will you write? 1 is related to A, 1 order pair you got. 2 is related to you, A, right? Then 3 will be related to B, 4 will be related to C. Do we have any more relations? No, not at all, right? One thing you might have observed, the number of arrowheads tells you the number of elements. That is also the thing. Actually, in the beginning only I told you number of rubber bands I asked, right? Okay, so you got this. Next, number 2, I am asking you about the domain. Same questions. Domain of R. What will be the domain of R? First place elements, right? You can see here, or you can see here also, the elements from where rays are going out, except 5, all are having some divergent rays, right? Rays going out of it. So 1, 2, 3, 4. Number 3, it is range. I am asking you range of R. What is the range of R? All elements which are having some pre-images, or all elements to which some arrows are coming. So only 3 elements are there, A, B, C. And in the fourth, if I ask you about the codomain, what is codomain? Yes, codomain is the most easiest part. No students make a mistake over here. Is the right hand side set. R from A to B. If somebody says B is the codomain, default, right? So we did this. Okay. So now one more question will be taking. Right? Please note this. Anyway, you keep on noting this. I am doing it here. Number 4. Question number 4. What I have to do? We are going to take a relation, this x r is equal to xy, where y equal to x square plus 1 and xy both are in natural number, right? Then number 1, find image of 3. Number 1, find image of 3. Number 2, find pre-image of 10. And number 3, find pre-image of 6, right? These are the 3 problems. Find image of 3. Okay, so if you want to construct a figure, you can do it for understanding. Say here what they are doing, I have to consider both n, natural number they have told. Now nothing else is mentioned. Only thing is that x and y are natural number. Means relation is from natural number to natural number. And relation criteria is what? X square plus 1. Means whatever x you take, square it and then add 1. That is what the right hand side element. If I choose 1 square plus 1, that is 2. 2 is the value of y. If I choose 2 square plus 1, that is 4 plus 1, 5. That means 2 will be related to 5. Did you get me? So if this is the case, how do I find the image of 3? Right? I am doing it in the figure. Afterwards we will do it very perfectly. Here it is 3. My relation tells you what? How does it related? The element is to be squared and plus 1. This is the criteria. Then the result is found here. 10. Did you understand what I did? So image of 3 will be 10. Image of 3 will be 10. Very nice. Image of 3 will be 10. So how do we find it? So directly we will write it like this. See, y, right? Y. We have a symbol, of course, that I did not mention. Now I am mentioning. Try to know that. If I write 3 here, it means I am talking about image of 3. Image of 3. So that is to be found by 3 square plus 1, that is equal to 10. That is equal to 10. Am I clear to you? Okay. So actually this notification, this symbol should be not modified like this. I am sorry, I should have written it like this. R of 3. That means 3's image with reference to the relation R. Done. This is done. Number 2. Pre-image of 10. Reverse they are asking. Acha, we have done it here, so we can say from here only that pre-image of 10 is 3. But supposing that the first part is not done, how will you say? So this time we will consider like this. Let x be the pre-image, right? X be the pre-image. Pre-image of whom? 10. X be the pre-image of 10. Therefore, what I can say? 10 is the image. How do I get it? X square plus 1. This is the rule. So from here, what will I get? X square equal to 9. So x will be equal to plus or minus 3. So thus we conclude, do we now conclude that x equal to 3 and minus 3 are the pre-images? No. Here be very, very particular. Once you get any result, make sure, verify whether you are satisfying the criteria or not. Check here. This would be natural number. So even if you are getting plus or minus 3, no problem, you can get it. But now while writing the final answer, make sure you drop minus because it is not included over there. Did you get me? So pre-image of 10 will be plus 3, right? Positive 3, not negative 3. Ho gaya? And now next, the last part, that is pre-image of 6 in a similar way, right? So I'll do the calculation here. You can see, right, a small calculation. So this time 6 will be equal to x square plus 1. So what is x square equal to? 5. So what x is giving you? Plus or minus root over 5. What can you say? Do we have a pre-image? No. Because root over 5, whether plus or minus, forget about that. It is not present in this n. So that means if I randomly pick also from elements in the range, I never get 6, right? That also can be concluded. So I can ask you this question also from here, that is 6 an element in the range? Did you get me how I am turning the question? Instead of asking you pre-image of 6, I can ask you, do we get 6 in the range? Or is it a part of range? Yes. So your answer will be what? No. We cannot get 6 as a element in the range. Did you get me? Of course, it is very much present in the codomain, but it is not present in the range. So we have done a good problem here. So now we will come to the last problem, and I do hope that after doing this, you will be able to finish the exercise. You will definitely finish the exercise. If you will be having any problem, please mention these things in the mail what I will be giving you in the description, right? Or you can personally, clear the doubts. Number 5. This problem actually I have chosen only because of its representation style, right? Sometimes we represent it like this, right? What is this? I'll tell you. X is a prime and x is less than 10. Right? We haven't written much, only we have written this much, and we should be able to understand what they are exactly trying to depict. Be very, very alert about that. X comma x cube. See, earlier we wrote x comma y, then we wrote y equal to something. Right? Now we are preserving the space. Instead of writing y equal to x cube here, why don't you write y whatever is the value? Right? Previous problem is here only. Instead of writing x comma y, where y equal to x square plus 1, like this, I could have written x comma x square plus 1, right? So this is a mode of expression which you should always understand. So you have got this. Now what is my question? What I need to find? Same domain, range and codomain, right? Codomain you cannot say here. Codomain you cannot say here because they did not mention anything very properly, right? From which set to which set, right? But domain, right, and range we can say. See, for domain I have to see this part. X is a prime number where x is less than 10, right? First of all, I missed one part. Let us write it in the roster form. Roster form if I write, can I take 1? Will 1 be applicable here? Not at all. 1 will not be applicable here. What's the reason? Because 1 is neither a prime nor a composite number. 2, yes, that's it. 2 will be there. So if I put 2, then this will be what? 2 cubed. That means 8. Correct? The next 3 is a prime number. What will be the image? 3 cubed. That is 27. 4. What will be the image? 4. What will be the image? 4 cube. 4 cube means 64. Right? Sorry. Will 4 be there? No. 4 will not be there because 4 is not a prime. 5. 5 is 125. Next is 7. 7. Then it is 343. After that, any prime is there before 10? No. 7 is the largest because 9 is not a prime. So this is the roster form. Then if I ask you what is the domain, domain will be 2, 3, the first place elements, right? And then if I ask you what is range, range of R, it is 8, 27, 125, 343, and then codomain. And now there is a question. You can guess, right? You can write it as a real number. You will be correct. You can write natural number also because results will be always natural numbers. Negative numbers will not come. So, worst case, if somebody asks you, write natural number, no problem. But otherwise, they will fix it from which set to what set. So, with this, today I will finish it. And I ask you to do this second exercise as a homework completely and do clarify if you have any doubt. Next video will be starting with functions. Till then you have to be very clear about relations, right? Any more queries, please do not hesitate to ask. Okay, bye.